Now the second crystalline form which we are going to study is the diamond. As you all are familiar with the diamonds and you know that diamonds are girls' best friend. So we are going to start with that allotrop, that is diamond, and we are going to learn that you can say that what is the structure of the basic diamond and how we can obtain actually. So diamond, you all know, is the purest form of carbon. And where it is found? It is found in deep mines and where? In South Africa, Brazil, Russia and Australia. These countries are actually rich in the diamond. So, and we can also prepare artificially by how? By subjecting graphite to a very high temperature. So, when we take graphite, we heat it in absence of air at very high temperature, it gets converted into diamond but the diamond here obtained is in the form of very small crystals. And what is the basic structure of the diamond? The diamond here, now you learn that diamond and graphite both are having a different structure. In the graphite diamond, each carbon atom is linked to 4 other carbon atoms like this, giving rise to a tetrahedral structure. And moreover, the bonds which are formed, they are very strong bonds. These are very strong bonds. So each carbon atom linked to 4 other forming a tetrahedral structure. Now you got it that in graphite it was hexagonal, here it is tetrahedral, and there the bonds were weak, it has a tendency to slip also the layers, but here the bonds are very strong, no slipping, nothing, therefore the diamond is very hardest substance known. Now looking on to the properties, it is colorless, transparent, hardest, brittle, density 3.5 gram per centimeter cube, bad conductor of heat and electricity. And the reason I think you got it because it is bad conductor because there are no such free electrons, but the graphite was good conductor. So you can see they differ in the physical properties. This is what we want to learn here, that allotrops have same chemical properties but different physical properties due to difference in the arrangement. Now what is the use basically? Used in making jewelry, you all know. Used in making radiation proof windows in space satellites, used for cutting and drilling rocks. So these are the basic use, but still it is used for many other purpose also. So this is what is the diamond. Coming on to the third crystalline form, that is fullerene. In fullerene actually many carbon atoms are arranged together forming a cage like structure which resemble just like a football, you can say. The carbon atom can range up to 200, 300 also there. And it is because first it was studied by Buckminster fullerene, therefore it is named behind its name, that is the fullerene. And if we look for the properties, we see that the fullerene is colored, but the color of fullerene allotrop actually depends upon the number of carbon atoms it contains. Moreover, it is soluble in the organic solvents, and if we heat it above temperature 1000 degrees Celsius or below 1000, it gets the cage actually breaks and the carbon atoms start getting separating. They are separated. Used as an insulator, and many cases it is used as a superconductor also. So this is what about the crystalline allotropic form of the carbons, where you can see that they are homogeneous with regular pattern. And now we are going to study about the amorphous form, where we will see that there is no such regular pattern. So we are going to look on the amorphous form of the amorphous allotropes, I must say that, of carbon. So we are going to start that.